Hello everyone, welcome to the resultant. So how are you all guys? Shall we start our session? Today's session we have a complete topic on design of beams. So quickly tell me, is the audio video clear? Is audio video absolutely fine? Okay guys, where are you all? So join the session. I want everyone in the class quickly. So we'll be discussing the topic design of beams. Okay? Design of beams. So design of beams. Okay? Design of beams. Okay, so like, share, and subscribe our channel. You will get the important topics regarding the EG examinations. Okay, you will get the practice sessions on our channel. So this is all about me. You can go through my profile. My name is Mohammed Shoaib, and these are the subjects which I have taught. Okay, for the students, I have the 2+ years experience in the teaching. Okay, next, Arvind. Hi. So we have an aim batch for you. Okay, it was for the RRB JE CBT 2 technical batch. Okay, so we have live recorded classes for you. Okay, live recorded class for you. We have PYQ solution, quiz solutions, test series will be there, and doubt solving sessions will be there for you. Okay, and you will get complete 400 hours of live classes. 400 hours of live classes. Okay, okay. Next we have New Year sales is on. That's we are giving flat 50% discount on all our courses. Okay, whether it is J course, whether it is Gate course, or whether it is any other course. Okay, all you have to do, you have to install the app, resultant app from the Play Store. Okay, so what is next for you? So in the AIM batch RRB JE CBT 2, we'll be discussing the RCC new subject. Okay, the date will be from the Monday, that is the 6th Jan. That will be the 6th Jan. Okay, guys. Okay, that will be 6th Jan. And also we will start the highway engineering on 10th January. Okay, for complete RRB JE CBT 2. Okay, Arvind. Arvind, कैसे हो आप? How are you? Okay, let us start then. Let us start the design of the beams. Okay guys, let us start. Okay, we'll start the design of the beams. So what is a beam? So I have told you in the classes that beam is the member which carries what? Transverse loading. Absolutely fine. Which carries the transverse loading. Absolutely fine. So in this video lecture, I'll be discussing the design of beams. So first we'll be discussing what is the effective span. What is the effective span for the beam? Okay guys, what is the effective span for the beam? So if I define the effective span, it's a portion of the beam that effectively participates in the bending. Okay, it is the portion of the beam. Absolutely correct. It is the portion of the beam which which take part in the bending. So I'll write down portion of the beam. I'll write down the effective span portion of the beam. Portion of beam effectively taking part in what? Taking part in bending. Absolutely fine. Taking part in bending. Taking part in bending. Or we can say the effective span is defined as the point. Okay, we can say that the distance between the two contrafluxure points, the consecutive two contrafluxure points. Absolutely fine. Okay, two consecutive contraflexure points. Let us suppose we have a beam here, simply supported beam. Okay, we have the simply supported beam resting on the supports. Let us suppose these are the supports on the beam. Okay, guys, these are the supports on the beam. Absolutely fine. Now, okay, so these are the supports of the beam. This beam is subjected to the overall loading. This beam is subjected to the overall loading. Absolutely fine. UDL load. Absolutely fine. So what will be the overall length of the beam? What will be the overall length of the beam? So if I define the overall length of the beam, the overall length will be from one end to the other end. That is from this end. Okay, from this end to this end. This will be the overall length of the beam. Absolutely no problem, guys. No problem. Okay, no problem. So this will be L overall. This will be L overall. Okay, this will be L overall length. Absolutely fine. Now, another point of discussion. Another point of discussion. So what is the effective length? So if I take the distance from the center of the support, from the center of the supporters, okay, that will be the overall length. That will be the, sorry, that will be the effective length. That will be effective length in case of this beam. Okay, we're having different conditions. This will be L effective. This will be L effective, guys. Okay, this will be L effective, guys. So if I if I take the case of the simply supported beam, let us take the case of the simply supported beam. Okay, so I am taking the simply supported beam. I am taking the simply supported beam. In case of simply supported beam, what is the effective length of the beam? It is the beam or the slab, remember. Okay, valid for both the beams and the slabs. So what is the simply support? What is the effect length in case of the simply supported beam and the length and the slab? Okay, okay. So let us suppose I have the simply supported beam here. I have the simply supported beam here. Okay, let the support widths are B1 and B2. That means the width of the supports are B1 and B2. Okay, so I'm taking the support width as B1 and B2, and I am taking the overall length is okay LC. Okay, I'll write down. Don't worry. So let us suppose this is B1, this is B1, and this is B2. Okay, this is B2, and the length between the supports, that is this length, is, let us suppose, LC. Okay, is LC. Absolutely fine. So in that case, I'll take the L effective. I'll take the L effective. How can we define L effective? L effective will be simply the minimum of, guys, the minimum of, okay, I'll write down the minimum of either LC plus, okay, B1 by 2 plus B2 by 2. Absolutely fine, B2 by 2. Okay, absolutely fine. Now let us suppose the depth of this beam, the effective depth of this beam is small d. The effective depth of this beam is small d. In that case, I will write down also the minimum of L effective will be minimum of clear distance plus half of the support width plus half of the support width. Okay, and I will write down also LC plus D. Okay, LC plus D. Absolutely fine. So this will be what? This will be the clear or the effective length of the beam. Okay, or the effective length of the beam. So वो minimum दोनों में जो minimum होगा, you have to take the support, you have to take the effective width. Okay. Now another case. Let us take the case of the continuous beam. So I have the continuous beam. Absolutely fine. So I'll make the case of the continuous beam. Let us suppose this is the beam. Okay, these are the beams. These are the beams. So this is one support here. Absolutely fine. So this is a continuous beam, guys. So this is another support here. This is another support here. Absolutely fine. So in that case, let the support widths be B1 and B2 again. So it is B1 and it is B2. And the distance between the supports is, let us suppose, the LC. The distance between the supports is LC. Absolutely fine. No problem, sir. No problem. The distance between the so and this is LC. Absolutely fine. Now let us take, okay, the effective depth as the D. So in case of the continuous beam, so it is the continuous beam. It is the continuous beam, guys. It is continuous beam. In case of the continuous beam, guys, if the support width is less than, so I will write down B1 or B2. I will write down B1 or B2. Okay. Is less than, I will write down is less than, okay, is less than LC by 12. So you have to check first LC by 12. Okay. And if the support width is less than LC by 12, then it will be taken as the simply supported beam, guys. It will be taken as the simply supported beam. So what does that mean? That is the effective length will be simply, okay, simply supported beam. The effective length L effective will be minimum of the case of the simply supported beam. That is, I can write down the LC, okay, plus B1 by 2 plus B2 by 2, okay, B2 by 2, absolutely fine. Okay, or I can write down LC plus D, LC plus D. The minimum value among the two will be taken as the what? Treated as the simply supported beam. Absolutely fine. Okay, absolutely fine. Now, I will check another condition. If the support width, guys, if the support width, that is the B1 or B2, okay, or B2 is greater than LC by 12 or 600 or 600 mm or 600 mm, absolutely fine. Whichever is smaller. So, दोनों में whichever is smaller, whichever is smaller. So in that case, guys, whichever is smaller, in that case, we'll be having the different, okay, L effective. So I will write down the L effective of the beam. I will write down the L effective of the beam. So in that case, the L effective of this continuous beam will be equal to what? It will be LC, sorry, minimum of, so I'll write down first minimum of, it will be minimum of LC plus D by 2. LC plus D by 2. Absolutely fine. Or it will be LC plus B by 2. It will be LC plus B by 2. Absolutely fine. LC plus B by 2. Okay, guys. Okay, guys. Absolutely fine. So it will be LC plus B by 2. Is everything clear? Is everything clear from this continuous beam? So first we have to check the LC by 12 condition. If the support width, either the support width is less than LC by 12, in that case I'll be taking the simply supported case, that is the L effective will be simply equal to minimum of LC plus B1 by 2 plus B2 by 2 or LC plus D. The minimum among the two will be taken as the value. Okay. Now, if the support width is more than LC by 12 or 600, whichever is smaller, in that case, L effective will be LC plus D by 2 or LC plus B by 2. Absolutely fine, no problem. Okay. Now, we'll be taking case of the cantilever beam. Okay, clear. We'll be taking case of the cantilever beam. Okay, guys, cantilever beam. So, in case of the cantilever beam, the L effective will be how much? The L effective will be how much? So I'll first make the cantilever beam. Let us suppose this is the built-in beam, absolutely free at the one end. Okay, free at the one end. In that case, I have to take the what? I have to take the simply supported beam. Let us suppose this is LC, this is LC, no problem, sir. This is LC, that is the clear distance LC. Absolutely fine, this is LC. And this is the depth D, guys. This is the depth D. Okay, so in that case, L effective will be what? In that case, L effective will be LC plus D by 2. LC plus D by 2. Okay, cantilever. Okay, L naught plus BW by 2 or L naught plus D, whichever is okay, absolutely fine. So it is simply LC plus D by 2. Okay, LC plus D by 2. So this is the effective length in case of the what? In case of the cantilever beam. Okay, in case of the cantilever beam. So these were the effective spanners. Very, very important topic. These were the effective spanners. Okay. Now we are designing the beam. So we'll be talking of the longitudinal reinforcement. Guys, we are talking of the longitudinal reinforcement. So I will write down the longitudinal reinforcement. Wait a second. I'll talk the longitudinal reinforcement. Okay. I'll talk of the longitudinal reinforcement. Longitudinal reinforcement. Okay, reinforcement. So longitudinal reinforcement, guys, the first case will be longitudinal tension reinforcement. It will be first case longitudinal tension reinforcement. Okay, tension reinforcement. Tension reinforcement. Absolutely fine. So how much will be the longitudinal tension reinforcement? That is we are providing for the tension to resist the tension, guys. Absolutely fine. In that case, the AST minimum, that is the required AST minimum. AST minimum, that is the steel required minimum. Okay, divided by BD. B is the what? B is the breadth of the beam. D is the effective depth. Okay. D is the effective depth. That will be okay. That should be greater than 0.85 by Fy. 0.85 by Fy. Absolutely fine. Okay. So this will be okay. This AST minimum is provided for what? Sir, this is provided to prevent the wolf, to prevent the sudden failure. That is, we are providing the ductility. Okay. So this AST minimum is provided. Prevent what? Sir, prevent sudden failure. Prevent sudden failure, to prevent the sudden failure, or for the ductility. Absolutely fine. For ductility, for the ductility, absolutely fine. And what is the maximum value? What is the maximum value for the AST maximum? Absolutely fine. So what is the AST? AST maximum value. Okay guys, AST maximum value, and that will be equal to 0.04. Okay, B times the capital D. B times the capital D. Sir, B is what? B is the breadth and D is what? D is the overall depth, not the effective depth, not the effective depth. So why there is the limit in AST minimum? Why there is the why there? Sorry, it is maximum here. It is maximum here. What is the why there is the limit of AST maximum? Because there should be not the problem of compaction. Okay, there should be not the problem of compaction. So we are limiting the AST. So problem of compaction. Okay, so this limit is provided for the problem of compaction. Absolutely fine. Problem of compaction. Okay, guys. Okay, okay, absolutely fine. Now, what I'll ask you a question. I'll ask you a question. So let us suppose, guys. Let us suppose I have the beam. Let us suppose beam. Okay, beam using what, sir? I am using fe415. I am using fe415. fe415. Absolutely fine. In that case, what is the percentage of, what is percentage of, okay, percentage of AST? What is the percentage of AST minimum? Anyone? What is the minimum percentage of AST minimum? Anyone? Write down the answer, guys. What is the AST minimum percentage? So quickly, I want the answers. So it is 0.204. Arvind is saying it is 0.204. So I can write down AST minimum. Okay, I can write down the AST minimum divided by BD. Sir, it is the percentage actually. Percentage of the steel reinforcement to the what? To the total area of the beam or the effective area beam. Sir, that should be equal to 0.85 divided by Fy. Sir, Fy value is 415. So I'll write down in the percentage. So I will get the 0.2%. Similarly, you can calculate for the FE 500. Absolutely fine. You can calculate for the FE 500. Now, now, I am taking the key. I am taking care of the what? I am taking care of the longitudinal compression reinforcement for the beam. Okay, guys, longitudinal compression reinforcement. I am taking care of the longitudinal compression reinforcement. Compression reinforcement. I'm taking care of the longitudinal compression reinforcement. What is the ASC minimum? What is the ASC minimum? That is, this compression reinforcement is defined as ASC. So what is the minimum value, guys? What is the minimum value? Compression maximum 4% of gross area. Okay, what is the minimum value? I'm talking of the minimum value. So if I write down the minimum value, so there is no limit. So I will write down ASC minimum. Sir, there is no limit. There is no limit. Okay, no value. Okay, but sir, at least we are providing two bars. Okay, but at least I'll write down, but at least, okay, two bars are provided, two bars are provided, or provided, absolutely fine. Okay, in compression zone, in compression zone, for what? In compression zone, okay, absolutely fine. For what? For ductility and to hold the strippers. For ductility, for ductility, and what? And to hold the stirrups, that is the steel stirrups, sorry. Okay, and to hold stirrups, and to hold stirrups. Okay, absolutely fine. So this is the limit of AST minimum. This is the limit of ASC minimum. Absolutely fine, guys. Now we will take care of the ASC maximum. Sir, what is the maximum limit of ASC? What is the maximum limit of ASC? That is the longitudinal compression steel reinforcement. ASC maximum is what? So what is the value? So Arvind say it is 0.04%. That 0.04 of BD gross area, or I will write down 4% of the gross area. 4% of gross area. So in case of the gross area, I am taking the capital D. So gross area, absolutely fine. Okay, gross area, gross area. So this limit is due to the problem of compaction, so that there should be no problem of compaction. There should be no problem of compaction. There should be no limit of, okay, problem of compaction. Okay, okay, is everything clear? Is everything clear? What is the ASC maximum? What is the ASC maximum? ASC maximum is 0.04 BD. Absolutely fine. Okay. Now I'll talk of the side face reinforcement. Okay. Side face reinforcement, guys. So let us take care of the side face reinforcement. Side face reinforcement. So when is the side face reinforcement provided? When is the side reinforcement provided? Okay. Side face reinforcement. Oh, you should remember, guys, when the depth of the beam exceeds 750 mm. Okay, when the depth of the beam exceeds 750 mm. So in that case, we are providing the what? We are providing the side face reinforcement. Let us take the beam, guys. Let us take the beam. So let's suppose this is our beam. Okay, this is our beam. Absolutely fine. This is our beam. अरविंद, ओके, आप स्कॉलरशिप लेना चाहते हो या नहीं? ठीक है, आप स्कॉलरशिप लेना चाहते हो या नहीं? अरविंद, प्लीज टेल मी. ओके, सो if this is the reinforcement, if this is the compression reinforcement, okay, so this is the tension reinforcement, this is the tension reinforcement. Okay, don't worry. So आप मुझे कांटेक्ट नंबर देना, ठीक है, या यहीं पर प्रोवाइड करो, ठीक है, तो फिर बाद में हम बात करेंगे. ओके, तो दिस इज द कंप्रेशन reinforcement, this is the tension reinforcement. So these are the stirrups. Okay, I'm making the view. I'm making the view. Okay, absolutely fine. So this will be the side face reinforcement. This will be the side face reinforcement. Okay, I'll take two rods of side face reinforcement. So this is the side face reinforcement. Provided when the depth of the beam exceeds 750 mm. Okay. So I'll write down first point. Provided when, I'll write down provided when depth exceeds depth exceeds 750 mm. Okay, 750 mm, absolutely fine. So when depth exceeds 750 mm, yes, 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 आपका 85% है, बिल्कुल बिल्कुल आपका 85% है. हाँ, तो आप ले सकते हो. हाँ, you can take the scholarship. Okay, so when provided when the depth exceeds 750 mm. Okay, so how much is the reinforcement provided? How much is the reinforcement provided? Sir, there is the limit, that is 0.1% of web area, 0%, 0.1% of gross web area. Okay, gross web area as what? As side face reinforcement. Side face reinforcement. What is the spacing? What is the spacing, guys? What is the spacing? The spacing should not be less than 300 mm. Okay, the side face. Sorry, the spacing. The spacing should not be less than. Should not be less than. Should not be less than what? Less than, guys. Should not be less than 300 mm. Okay, 300 mm. Okay, that means if you are providing 0.1% of gross web area, that means you have to provide it equal reinforcement on both these sides. That is on the left side and right side of the beam. Okay, that's on the left and right side of the beam. Okay, so this is the side face reinforcement. Also when the beam is subjected to torsion, in addition to what? In addition to forces, absolutely correct, there is the torsion in the beam also. Then in that case, side face reinforcement will be provided only when the depth exceeds 450 mm. Okay, so you should remember this. Wait a second, you should remember this. So I will write down, you should remember this. You should remember this, guys. So when there is torsion, when there is torsion in the beam, torsion in beam, absolutely fine. Okay, so in that case, side face reinforcement. In that case, side face RF. How much is side face RF? Okay, side face reinforcement is provided only, okay, only when depth exceeds, only when depth exceeds 450 mm. Okay, 450 mm. So you should remember this point also. Okay, you should remember this point also. Arvind, you should remember. So when the depth exceeds only 450 mm, in case of the torsion acting on the beam. Absolutely fine. Now we'll take care of this nominal cover. We'll take care of this nominal cover. What is the nominal cover? What is the nominal cover? Anyone in the class? Anyone in the class? What is the nominal cover? What is the nominal cover? So let us take the case of the nominal cover. Okay, let us suppose I have the beam. This is the beam. Okay, so I am providing the tension reinforcement in the beam. I am providing tension reinforcement in the beam. Absolutely fine. Tension reinforcement in the beam. Okay, so I am providing the tension reinforcement in the beam. Please like the section also. Okay, so this is the tension reinforcement in the beam. Sorry, wait a second. So this is the tension reinforcement in the beam. Okay, guys, this is the tension reinforcement. This is the stirrup. Okay, so what is the nominal cover? The nominal cover will be calculated. The nominal cover will be calculated from this, that is outside of this shear stirrup to the, okay, to the nearest compression fiber. That is this. This will be the nominal cover. Nominal cover, absolutely fine. Okay, now what is effective cover? The effective cover will be taken from the center of the reinforcement. Okay, so this is not exactly the diagram, but it will be taken from the center of the what? Center of the reinforcement. Sir, this is the effective what? This is the effective cover. This is effective cover. Okay, this is effective cover. Okay, so why we are providing this nominal cover? Okay, so minimum nominal cover is governed on the basis of following criteria. So I will write down minimum nominal cover, minimum nominal cover, okay, is governed by following condition, guys. What is the condition? The first condition, sir, it is the type of the structure member, whether it is the beam, whether it is the slab, whether it is the footing. So we'll be providing different what? We'll be providing different nominal cover. So I'll write down type of structure. It depends on type of structure, guys. It depends on type of structure. Okay, So the type of structure means it should be beam or it can be column. Anything, guys. Okay, anything. I'll write down what is the value. What is the value? I'll write down. Don't worry. So second point is the exposure condition. What is the exposure condition? That is the concrete is subjected to what type of environment? So exposure condition, absolutely fine. So that means it is the mild condition, it can be moderate condition, or it can be severe, very severe, anything, guys. It can be anything, absolutely fine. Okay, now another, it is the fire resistant. Okay, it is the fire resistance of the structure. Fire resistance of the structure, it is the fire resistance of structure. Absolutely fine. Fire resistance of the structure. Okay, guys. Okay. Now, let us take the case of the IS456. A very, very important discussion. Let us take the case of IS456. And let us take the case of SP34. Wait a second. SP34. These are the two codes. SP34. So, according to IS456, in case of the slabs, we are providing 20 mm of cover. Okay, but according to SP34, we are providing 20 mm of cover. In case of the beams, we are providing what? 20 mm of cover. Okay, but according to SP, we are providing 25 mm cover. Okay, 25 mm cover. Guys, is everything clear? Okay, for the case of the column, we are providing 40 mm in both the codes, that is IS436, IS456 and SP34. Absolutely fine. And in case of the footing, guys, in case of the footing, we are providing 50 mm and 50 mm. Is everything clear? Is everything clear, Arvind? Should I proceed? So this is the nominal cover. Decided on the following criteria, that is type of the structure, exposure condition, yeah, fire resistance of the structure. Okay, so footing it is 50, absolutely correct. Or or you may take dia of the bar. You have to take these values into the consideration, or dia of the bar. So I'll write down here, or dia of the bar, dia bar or dia bar, whichever is greater. दोनों में whichever is greater. So you have to take dia of the bar, or you have to take these values. Whichever is greater, that will be the nominal cover. Okay, whichever is greater. Absolutely fine. Is everything clear? Is everything clear, guys? Everything clear? So this is what? This is the nominal cover criteria. This is the nominal cover criteria. So we are discussing the beam, design of the beams. So we'll be discussing what? Maximum permissible crack width in RCC structures. Okay. So let us take the case of the maximum. Okay. Okay. So first I will discuss the maximum permissible crack width. Then we will discuss the lateral stability. Don't worry. So I'll case the maximum permissible crack width. Okay, in RCC structures. Okay, so it depends upon the condition, exposure condition. So let us take the first condition as mild. Okay, mild condition. So what is the mild condition? What is the mild condition in case of the cracks? Mild condition. So the cracks are not harmful, guys. The cracks are not harmful. Cracks are not harmful. Cracks are not harmful. Absolutely fine. Okay, so in that case, the maximum permissible crack width will be 0.3 mm. 0.3 mm, not the 3 mm. 0.3 mm. Okay, now another case is the moderate case, guys. Moderate and severe condition. Moderate and severe condition. Severe condition. So in that case, guys, in that case, the cracks are harmful. Cracks are harmful. Okay. So in that case, we are reducing this maximum crack width to what? 0.2 mm. 0.2 mm. Okay. Now another is very severe and extreme condition. So it is very severe and extreme condition. So in that case, guys, we are taking the value as what? In that case, we are taking the value as 0.1 mm. Absolutely fine, Arvind. Absolutely fine. So we are taking the what is 0.1 mm. Okay. So Arvind, we are starting the new subject. Okay. We are starting the new subject, highway engineering and RCC. Okay. So if you are purchasing the batch, do it today. Okay. On this Monday, we are starting the lectures. Okay, we are starting the lectures. I promise you, okay, one by one point will be discussed in the class. Okay, one by one point will be discussed in the class. You won't even miss a single concept from RCC. Okay, so this is my promise to you. Okay, Arvind, but you have to purchase the badge. Okay, very severe and extreme condition. Okay, guys. Okay, absolutely fine. So this was the what? This was the case of the maximum permissible crack width. Okay, maximum permissible crack width. Absolutely fine. So now we will discuss the lateral stability. We'll discuss the lateral stability. Now, if we are checking the lateral stability of the beam, so let us suppose the first case will be the lateral stability. In case of the lateral stability, we are first checking the laterally supported at the ends. So the first condition will be laterally supported at the ends. Laterally supported at ends. So in that case, you have to check the L unsupported length. L unsupported length, absolutely correct. So L unsupported length, it should not be greater than, minimum of, okay, so minimum of 60B, or I will write down 250B square by D. 250B square by D. Okay, guys, 250B square by D. Absolutely correct. But I mean, that is the case for the cantilever beam. So I will take the case of cantilever beam. So in case of cantilever, we are checking this stability criteria. That is, we'll be discussing what? L unsupported. L unsupported. So in that case, L unsupported will be how much? L unsupported will be, should not be greater than minimum of, okay, 250B, 250B or 100B square by D. Okay, so correct yourself, 100B square by D. Okay, now what is B, sir? B is the breadth of the beam. B is the breadth of the beam. Okay, breadth of beam. And what is D? D is the depth of the beam. Depth of the beam. Okay, depth of beam. So this is the criteria regarding the lateral stability of the beam. Okay, if the length provided is not greater than the values provided here, that will be what? That will be a stable beam. That will be the stable beam. Okay, that will be stable beam. Absolutely fine. So that will be stable beam. Okay, guys, that will be stable beam. Okay, let us okay. Now we are taking the arrangements of different loading condition. We are taking the arrangements of different loading condition. Okay, to get the maximum sagging moment, to get the maximum hogging moment, to get the maximum support moment, to get the maximum hogging support moment. Okay, so let us take the arrangement of the loading. So I'll take the arrangement of the loading. Arrangement of the loading. So in case of the beams, arrangement of the loading to get the maximum bending moment. Okay, for maximum bending moment. So I'll take the first case for maximum sagging span moment. So I want to calculate first. I want to calculate maximum. I want to calculate. हाँ syllabus तो पूरा complete होगा. Absolutely correct. So maximum. I'll take for maximum. Okay, sagging. For maximum sagging span moment. Okay, span moment. So in that case, for maximum sagging span moment, absolutely fine. In that case, so I'll take the arrangement. Guys. So let us suppose this is our continuous beam. This is our continuous beam. Okay, there are various spans. So I need to get the what? Criteria regarding the maximum sagging span moment. Okay, maximum sagging span moment. So let us take the span into the consideration. Let's suppose this span is taken into the consideration. Okay, so I'll be placing the load on that very span, to get the maximum bending moment plus the alternative spans. Okay, plus what, guys? Plus the alternative spans. Absolutely correct. So what should be the condition to get the maximum sagging span moment? Sir, it is nothing but the load should be placed on that very span and on the alternative span. Okay, and all the on the alternative span. So I'll write down. Okay, on that span, on that span. Okay, and plus alternative span, plus alternative span. Absolutely correct. Absolutely correct. Okay, another case of discussion, guys. So I will take the second case for maximum hogging span moment. Now I should get the, I should get what? I should get for maximum, guys, maximum hogging span moment. Okay, hogging span moment, hogging span moment. So in that case, I'll take another case of the beam. I'll take another continuous beam. Okay. So let us suppose this is continuous beam. Sorry guys. This is the continuous beam. Absolutely fine. Okay. Now there are various spans in the beams. So what is the condition to get the maximum hogging span moment? Hogging span moment. Maximum hogging span moment. Okay. So let us suppose this span is in consideration. This span is in consideration. The load should be placed adjacent to the spans. Adjacent to the spans plus the alternative spans. The load should be placed adjacent to the spans plus the alternative spans. This is the condition. This is the condition, guys. Okay. So I will write down load should be placed. So load should be placed, guys, where load should be applied, load should be applied where, guys? Okay, adjacent to the span, adjacent to span plus what, plus alternate span, plus alternate span. Okay, so these are the conditions of maximum hogging span moment and the sagging moment. Okay, now there may be the case of the what, maximum span, maximum support moment, guys. Okay, maximum support moment. So I'll write down maximum support moment. Okay, I'll write down here maximum support moment. So the condition is maximum support moment, maximum, okay, maximum sagging support moment, positive support moment. In that case, I'm taking the beam. I'm taking the beam, guys. Okay, sorry. I'm taking the beam. This is our beam. Okay, so there are various supports. Let us suppose this support. On this support, I want the maximum sagging. Okay, support moment. So what is the loading condition? In that case, what is the loading condition? I'll write down. Don't worry. I'll write down the loading condition. Don't worry. So what is the loading condition now? What is the loading condition? So the load should be placed where? Load should be applied on next to adjacent spans. Next to adjacent spans plus the alternative spans. Okay. Plus the alternative spans. Okay. What is the condition now? Load should be applied. Load should be applied where? Load should be applied. Load should be applied. Okay. Next to adjacent spans. Next to adjacent spans. Adjacent spans plus alternative spans. Plus alternative spans. Absolutely correct. Now the last case, guys. Last case, in case of the maximum hogging support moment. In case of the maximum hogging support moment. So maximum hogging support moment. So what is the condition? In case of the maximum hogging support moment, what should be the condition? What should be the condition? Wait a second, guys. Okay. So let us take the case now. Let us take the case now. Maximum hogging support moment. Okay. So let us suppose this is our beam now. Okay. So I have to get the maximum hogging support moment on that way. This very support. Okay. So there are various supports provided. So what is the condition to get the maximum hogging support moment? The load should be placed on the adjacent spans plus the alternative spans. So this should be the loading. Okay, the load should be placed on the adjacent spans. Okay, plus the alternative spans. Plus the alternative spans. Absolutely fine. Okay, so load should be placed what? Load should be placed. Load should be placed at what? At adjacent spans. Adjacent spans plus alternative spans. Plus alternative spans. Okay. Okay, guys. So this was today's class. Okay, done with the today's class. Arvind, done with the today's class. Guys, okay, we are having a batch for you. Okay, and we are starting the new subjects. So this is the aim batch for you. This is the aim batch for you. Okay, this is the aim batch for you. So you will get the PYQ solutions there. You will get the PYQ solutions here. You'll get the quiz. Okay, you will get the test series. You will get the doubt solving sessions. Okay, you'll get the 400 hours of live class daily. Okay, 400 hours of daily live class. So how was the class? Arvind, rate my class. Okay, and now we are having the 50% okay flat discount on our courses. The valid offer is from the 1st January to 5th January. Okay, whether it is gate course, whether it is ESC course or any other course, the offers are valid okay till the 5th Jan. Okay, till the 5th Jan. Then after, okay, we are starting the new subject is on our batch. Okay, that is RCC is starting from the Monday. That is from the January 6th. Okay, from the January 6th. Arvind, okay, if you are buying a batch, do it tomorrow. Okay, you won't miss a class then. Okay, and also there is the 50% discount. There is a 50% discount. This offer is valid okay till the 5th Jan. Guys, this offer is valid till the 5th Jan. Okay, okay, and another subject we are starting the highway engineering. Okay, we are starting the highway engineering on the 10th Jan. On the 10th Jan. Okay, and also there is the 50% off on all the courses. This is valid till 5th Jan. Okay, till 5th Jan. Okay, guys. Okay, so this was today's class. We have discussed the design topic regarding the beams. Okay, design topic regarding the beams. Okay, guys. So thank you so much for joining the class. Thank you. Okay, keep loving. Okay, keep liking our sessions. Subscribe our channel, and also guys, share the session as much as you can. You are getting a good content from our channel. Okay. Okay. So thank you so much for joining the class. Thank you, guys. Thank you so much for being with us. Thank you. Thank you, Arvind. Thank you so much.